So what to do over here? Tension given to us. We can mark here normal this way. This is normal. Lambda is the mass in the string per unit length mass lambda. So for this length, we will write lambda rd theta as the mass. And this mass will act vertically downward on weight front. So G vertically downward being marked. What are the equation which we may write over here? We know that tension is owing to string internal forces and this part will experience some force of friction. It is trying to pull it down, so there will be some force of friction also experienced by it. If it's not to slip, there will be a force of friction. Force of friction can be marked as Fs if it is not slipping. Then can be said from here that tension here on this part, tension here on this part is T is equal to mg, and tension here on this part T2, T1, if we mark this as T1 and this as T2, right? Right. So from T1 to T2 tension is varying over the pulley. At any point in time, what can be the tension marked? That is my first aim. The objective here is to get tension as a function of theta or mu relation with mu naught. So tension vary across the loop from T1 to T2 at any point in time. Tension is taken as T and T plus dt at any point in time at any position. T plus dt, force of friction will act in this direction. Force of friction maximum value will be mu into normal. We need to calculate normal as it can be reckoned from here. Mg downward, Mg is this much to us. Component of Mg can be taken from here. This is Mg to us. Let us take the two components. This being theta, this is 90. This will be 90 minus theta as we can see. So this angle towards is 90 minus theta and this way it will be theta. What can we say about mg then is normal force can be equated to lambda r g d theta, and as we got to see the angle will be 90 minus theta, so cos of 90 minus theta will get us sine of the angle theta. Cos of 90 minus theta will get us sine of the angle theta. That is what we got from there. That is normal, small normal on that portion. Writing equation of motion t minus t plus dt, and then minus of fs maximum. If we are to take maximum the moment when it is about to slip, then will be marked as mu or mu naught, taken mu naught. So mu naught into normal. Now what is normal to us? Lambda r g sine theta d theta. This is what we are getting, and these forces should be equal to, as per what being stated over here, these are the ones. These should be equated to, it should not slip in this direction, there should not be any motion, it should be stationary, so is equal to 0. Is equal to 0. How then the tension is to vary? We get from here minus of dt, negative of dt, and taking it to the right hand side, lambda r g mu naught sine theta d theta become positive, so putting it on that side. But this is what we get to see from it, t minus t and then dt. From there you got to that side and you got dt is equal to this much. So tension is what we get to see from here, this much. Tension is to vary from where to where, that is known to us. See, if this is not to slip, which is what being asked, if this is not to slip, then T maximum which we can get is up to T2 will be mu into M2G, mu to normal. That can be the value of T2. We don't want it to slip, so that can be the value of T2. And from this equation, if we reckon this equation, what we get to know then, that we can vary tension from where to where. Tension can be varied from here. What is here? The tension is M1G to a value of tension which can maximum go up to mu m2g. I think this is clear to all of you. It can maximum rise up to mu m2g. And from where to where the angle is to be varied, the angle is to be varied from where to where, theta is equal to 0 to theta is equal to pi by 2. This is a variation on the angle, right? Check if there is anything missed, any part which is mixed. We can add on to those part, mu into normal, tension, dt, fs, normal, everything is fine with us. One may say that these two tensions will not be same, so there will be a component of tension. See, if that is to be taken, certainly the tension will not be same, there will be d theta term. You have to incorporate it, then from this equation that incorporation is possible. I'm not saying that you should not look into that prism angle. From that prism angle also, we'll be able to see that tension will have a component. Just a moment.